So now we know the capacitance of a parallel plate capacitor which is partially filled with a dielectric. Now we are going to discuss a different case, that is, this was our previous problem and the answer for capacitance of a parallel plate capacitor which is partially filled with dielectric, it was epsilon 0 A divided by D minus P plus D by K. Okay, let me read this. Now the situation is we are having a parallel plate capacitor. This is our parallel plate capacitor connected to a battery. In this case, we are adding a conducting medium of thickness T between the plates of the capacitor. Is it a dielectric added between the plates of the capacitor? No, we are adding a conducting medium between the plates of the capacitor. The thickness of the conducting medium that we are adding over here is T. As we know, the distance between the plates of the capacitor, it is D. Okay, this is our new situation. We have to find out the capacitance of the capacitor. For finding out the capacitance of the capacitor, can you recall what is the dielectric constant of a conductor? That is the epsilon R for a conductor. You might have learned in your first chapter, or if you didn't learn, you just know it now. The dielectric constant or permittivity of medium for a conductor is infinity. It is infinity. Okay. Then we could say electric field intensity in medium, it was electric field intensity in air divided by K. That means in this case electric field intensity in medium, it will be, let me delete this, it will be E air divided by infinity. Number divided by infinity is 0. Therefore, it's an important point. Electric field intensity in medium, that is electric field intensity over here, it is 0. Okay, as usual, we'll start writing total potential between the plates of capacitor will be potential where air is situated plus potential where we are having medium. And we know potential is equal to electric field intensity into distance of separation. Therefore, potential in medium will be electric field intensity in medium into distance. That means 0 into distance. That means this term will become 0. Therefore, I could write total potential is equal to what's potential of air? Potential of air will be electric field intensity in air into distance where air is there. In this case, the distance where air is there is D minus T. കാണാം നമുക്ക് ഇവിടെ നോക്കുമ്പം ഈ ഒരു റീജിയനിലാണ് എയർ ഉള്ളത്, അത് D minus T thicknessലാണ്. Plus, what is potential in medium? Potential in medium is also 0. Since electric field intensity in medium is 0, the potential in medium is 0. Then, what was electric field intensity in air? It was sigma by epsilon 0. It can be written as Q by A epsilon 0. Therefore, total potential between the plates of capacitor, if I am substituting for electric field intensity in air, it is Q by A epsilon 0 into, it is D minus T. Now we know the potential, and from this, if I am retaining this Q and if I am taking this V and taking all the side, Q by V is equal to, we could write like that also, A epsilon 0 divided by D minus T. Clear? What's Q by V? Q by V is C. Therefore, C is equal to epsilon 0 A divided by D minus T. This is the capacitance of a parallel plate capacitor if it is partially filled with a conducting slab. The conducting slab is of thickness T. Okay, remember this formula also. Okay, now let's speak about polarization of dielectric. That is, As we know, if we are adding a polar dielectric or a non-polar dielectric between the plates of the capacitor, its capacitance will increase and the individual molecules of the dielectric will align according to the external electric field. We have learned it in our previous sessions. Therefore, the arrangement of or the alignment of individual molecules according to the external electric field is called polarization. The phenomena by which individual molecules will get aligned according to the external electric field, that phenomena is called polarization in dielectric. Okay, therefore polarization, it is denoted by the letter capital P. And it was experimentally found that polarization is directly proportional to external electric field. If we are increasing the external electric field, the extent up to which the molecules are getting aligned is also increased. അതായത് ഇലക്ട്രിക് ഫീൽഡ് കൂട്ടുകയാണെങ്കിൽ ആ മോളിക്യൂൾസ് അറേഞ്ച് ചെയ്യുന്നതിന്റെ ഓർഡറും ഇൻക്രീസ് ചെയ്യും, നല്ല കറക്റ്റ് ആയിട്ട് അലൈൻ ചെയ്യും. അത് ഇലക്ട്രിക് ഫീൽഡ് വളരെ കുറവാണെങ്കിൽ മോളിക്യൂൾസ് അത്രത്തോളം കറക്റ്റ് ആയിട്ട് അലൈൻ ചെയ്യും. Therefore, polarization is directly proportional to external electric field. And we could say polarization is equal to some constant into electric field. In this case, we will write it is epsilon 0 chi e into E. The proportionality constant that we are using over here is epsilon 0 chi e. And you know who this is. Epsilon 0 is permittivity of free space. Now there is a new constant, that is chi e. It is electrical susceptibility. What's it? It is electrical susceptibility. Therefore, this is one important formula that you have to learn in polarization of dielectric. Polarization is equal to epsilon 0 chi e into E, where epsilon 0 is permittivity of free space, chi e is electrical susceptibility, E is external electric field, P is polarization. Polarization is denoted by the letter capital P. Okay.